autonomously in the United States. My name is Michael McLaughlin. I'm a research analyst at the Information Technology and Innovation Foundation, or ITIF for short. Today, we're going to be talking about autonomy in a wide range of delivery technologies, ranging from drones to robots to vehicles to freight trains. For each of these areas, we will discuss how organizations are using autonomous technologies and how we can increase their adoption. And we have a great group of panelists today to have that discussion. We have John Graber, who is president of the Aerospace Unit at Workhorse, which designs and manufactures electric delivery vehicles and autonomous drones. We also have Warren Stubbs, who's the director of information systems development at Norfolk Southern, which is a major transporter of industrial goods and operates railroads in 22 states plus DC. And then finally, we have Greg Rogers, who is host of the Mobility Podcast and the former director of government affairs and mobility innovation at Securing America's Future Energy. Before we begin, though, I do want to mention how our audience can participate in this conversation. We invite you to ask questions at any point. And if you're watching on ITS website, please click the link to ask questions on Slido. And if you're watching on YouTube, then please follow the link in the event description. I would first like to start with, though, the current state of automation and the benefits of introducing automation into delivery. So John, I would actually like to start with you, since I know Workhorse completed a test in April with UPS and others to test how drones could assist in the response to coronavirus. So can you talk about that test, but also talk about how Workhorse has combined drones and electric vehicles in general and the benefits of doing so, please?
Yeah, thanks, Michael. I appreciate your having us on. Workhorse is a last mile solutions company. We build electric vehicles. We have a patent for launching drones off of our electric vehicles to take them out to the world and work on how to most efficiently get stuff where people need it fast. The goal of the test in April was working with Drone Up and UPS in the state of Virginia to understand what standoff delivery, low touch deliveries might look like, and what could you do if it was required to move material can't go. The test was run by Drone Up. Those guys did a great job of helping figure out what the art of the possible looks like. At any given time, there were as many as 7 or 8 aircraft in the air, working beyond visual line of sight, with visual observers, without, trying to understand what it looked like to deliver things very high precision, very high volume in daylight and dusk operations. We had really good operations ourselves, flying on and off of our truck. We did 54 lifts in 3 days. The whole organization did hundreds of lifts in 3 days. Our part was about 50 plus. And with our aircraft and our vehicle, programmed to carry about 10 pounds, about 10 miles. And all the lifts we did for the test were much shorter than that, but we demonstrated that it's something that can be done, and the capability exists today. I'm glad you started by talking about automatic and autonomous. We did a lot of automatic operations, but none of it was completely autonomous because we have people in the loop watching everything we do for 107 operation in particular. And the tests were all around how to augment 107 pieces so you can most safely and reliably get things where they're needed. I'll be quiet and let more people talk.
And could you just expound a little bit, though, on kind of what are the general benefits in terms of speed or cost of delivery for automatic or for autonomous drone delivery?
Oh, sure. So in the package delivery world that we live in, the last mile delivery world that we think about, the standard big package delivery van that everybody is familiar with, seeing it on the street, DHL, UPS, the post office, FedEx, Amazon, whoever you pick, those vehicles are running around, if they're not electric, sub 12, 13 miles a gallon, maybe $1 a mile in fuel costs, maybe $2, $3 a mile in terms of maintenance costs. And they're, call it an 11,000 pound empty weight vehicle that is moving around with all of the packages inside that don't weigh nearly 11,000 pounds. So the real brilliance of drone work, besides the notion that we can lower cost is that it's the much smaller footprint for what you're actually delivering. So you're able to match more, instead of 11,000 pounds to deliver a 1,000 pound envelope, we're using a 24, 25 pound vehicle to deliver 5 or 10 pounds. Just the carbon footprint piece of that alone, how much less mass you're moving around to take care of people's needs is really significant, and people don't think about that enough. Our cost of delivery, if you want to use the proxy for efficiency and use cost to do that, our cost for delivery is on order of magnitude 100 times less for every mile we drive a drone than you drive the truck. So it's a really compelling argument as long as you can be as safe and reliable as the surface transport. And that's the part that everybody's working to get right.
Greg, I'd like to bring you in here now. Could you just talk about kind of how else we've seen autonomous delivery technologies being used during the pandemic?
Yeah, certainly. One of the things that has stood out in the past few months is how much contactless delivery has really come to be something that everyone is familiar with and recognizes the benefits of. And it's drawn a lot of attention to the autonomous delivery space. I'd like to point to, Neuro, for example, started to deploy its vehicles in Sacramento to help to respond to this crisis and actually help to deliver supplies to people who were being treated in the sleep train arena. And it's a meaningful contactless sort of delivery, and it points to what I think is really a broader realization of one of the additional benefits of autonomy. As John had mentioned, on a broader scale beyond COVID, we don't necessarily need an 11,000 pound vehicle to be delivering an 11-pound package, right? And purpose-built autonomous vehicles can definitely help to address some of the issues that we have with conducting deliveries more efficiently, and also in this pandemic and in future emergencies, can help to provide a service that reduces the risk of transmission and also gets people the medical supplies or the groceries or other items that they might need.
Mm-hmm. Now, Warren, I'd like to bring you into this conversation as well now too. I feel like rail in general, when we think about autonomous technologies and transporting goods, sometimes gets kind of left behind in people's minds. So could you talk a little bit about kind of the automation that's already happened in the industry, what we could see in the future, and kind of what benefits have we already seen?
Sure, Michael. And before I do that, let me touch on a topic or extend a topic that John mentioned earlier about the use of drones. That's a good example in the rail industry where we are beginning to use drones for bridge inspections. Traditionally, we would have humans participating in a dangerous activity to inspect the structure of the many bridges across the rail topography across our country. And now we're beginning to use drones that have very high resolution images that can assess any sort of maintenance that's needed, any sort of stress or fractures, and it gives us the ability to very quickly and efficiently capture needed inspection points. Another pilot project that we currently have underway at Norfolk Southern is the use of drone technology to actually identify mechanical defects on rail cars. So here's how it would work. We have a rail yard that literally has dozens of tracks, has hundreds of cars, and we have the ability to fly a drone in between those cars and use image analysis, capture images and look for defects in the couplers or in any of the wheel areas on rail cars. So that pilot project is underway and we're making great progress there in terms of using drone technology along with some level of image analysis or predictive analytics to determine that a rail car might need to be maintained. Jumping into probably the most common point of interest has been positive train control. And positive train control is one of the capabilities that all the Class 1 railroads and other railroads are deploying here in the North American continent. Positive train control allows us to place an onboard computer that communicates with GPS, and it also communicates with the back office. It communicates with wayside signals and wayside sensors to ensure the safe movement of trains across the entire rail network. And traditionally, we've seen that as a regulatory requirement. But of late, over the last couple of years, we've really looked at that as a leverage point for IoT, capturing data from sensors deployed in the field and bringing it into the back office to trigger improved business processes. So positive train control has certainly been a big step forward in the rail industry. One last topic on the positive train control, it provides the umbrella of safety for the train movements across the rail network. But there's another product that was installed across most of the railroads early on, and it's called energy management. There's an onboard computer that helps us arrive at autonomy or automation. And this onboard energy management computer looks out in advance, roughly 8 miles in advance, and determines how much throttle is needed in order to traverse that section of the network. And so in essence, it is very much like the auto control that you have on your car. You punch the button and your own cruise control, if you will. And then PTC provides the umbrella of protection across that. And so it really works hand in hand. And those two have really launched the rail industry forward in terms of autonomous travel.
So now that we've, I think, started to talk about some of the different benefits, I want to turn back to you, John, and just talk about, I've heard a lot about different tests, and I know we've started some commercial drone delivery programs here in the United States recently. But what are the hurdles to making something like, making drone delivery part of day-to-day operations in the United States?
Oh gosh, so I'll start at the macro and we can get down to the micro. The biggest hurdle is safety and reliability that build community acceptance so that we can all agree that it's okay to have 50 or 80 drones flying around us on any given day. We go out in the neighborhood. We've been testing commercial deliveries for over 3 years at Workhorse, and we work with people who have been doing it longer than that. And what you find is there are people, and you guys are friends and neighbors, everybody we know, there are people who like the idea a lot, and there are people who are somewhat resistant to the idea of a drone delivery in principle. When they actually see it, we have almost universal acceptance with the product and how ours works. We pay a lot of attention to noise control. We pay a lot of attention to absolute safety control. For instance, when our aircraft is inbound to your house with a package for you, it means that you have opted into a system and you have an API and something built on your phone, Android or iPhone, that allows you to say, oh, I got a notification, the aircraft's inbound, I picked where it's gonna land, I'll go outside, it will come over my house, it'll winch the package down and leave. Oh, my dog got out, what do? I can't let it land. I'll tell them they're going to recall the aircraft. It's not going to come today. We'll figure out a time it comes tomorrow. Those are the kinds of things that you have to get right. So from a macro level, you have to be safe and you have to be reliable or the community won't let you in. And if the community doesn't let you in, it really doesn't matter what else you can do or what kind of value you can bring. So the real air you breathe, the fundamental threshold is, are you safe? And are you reliable? And can you do it 100 out of 100 times? And for the 1 out of 100 times when you can't do it, is it something that's going to disrupt the neighborhood, or is it going to be a fail-safe failure mode that allows people to look at it and say, okay, I can live with that? In every neighborhood, there are going to be places that everybody would agree a drone should not fly. Over a schoolyard, over a church, over a hospital, those kinds of things. But I think everybody can agree on places drones can fly. And working with a neighborhood, it's pretty easy, especially if you're someone like the post office or an Amazon or even a large drugstore chain, to go out and canvass a neighborhood and say, how many addresses want to participate in drone delivery? And what does that look like to you? And when would you like it to occur? And when would you like it not to occur? What are the rules you'd like to set up? Getting all of that in place is extremely important. And the use of the word obstacle is not something we like to use. It's more of a milestone. How do you get the things done that allow people to accept the notion of the value you bring? Because once everybody understands, my neighbor is 90 years old, she doesn't want to get out today, but there's something at Walgreens or CVS for her to get. Well, gosh, if CVS had a drone on their roof and they could send it to Aunt Mary's house and put it in her front yard, and she doesn't have to get in her car, or her son doesn't have to come over, and it's zero contact because it was cleaned at the source, and now she's the only one who picks it up. How do we enable things like that? Once people understand that you can do it in a way that doesn't bother anybody, acceptance grows and grows and grows.
Greg, I'd like to kind of pose a similar question towards you. You know, what are the milestones when you think of, say, autonomous vehicles taking part in autonomous delivery or autonomous kind of sidewalk robots? What are the milestones that they have to hit, and you know, kind of what do we need to do?
Yeah, first of all, we've seen a major milestone this year already. As many who are watching may know, in February, the National Highway Traffic Safety Administration, NHTSA, provided Neuro with permission to deploy 5,000 vehicles that are purpose-built. They're roadworthy and are electric and autonomous and can conduct deliveries. And these are vehicles without steering wheels, brake pedals, side mirrors, things that are traditionally required under Federal Motor Vehicle Safety Standards, or FMVSS. That was the first step, one major first step that we've seen from the federal government in permitting vehicles with new designs to be deployed. And it's part of a larger trend in federal motor vehicle regulations, is making the required updates to enable autonomy, real purpose-built autonomous vehicles. But we still have a structure of Federal Motor Vehicle Safety Standards. They're written before autonomy was really considered to be a possibility. For example, there are a lot of mentions in motor vehicle standards, which every vehicle on the road has to comply with unless they receive an exemption, which refer to a human driver, to driver's seats, to the driver's steering wheel. And an autonomous vehicle that's purpose-built, that does not have human controls, and which meets basically the same safety standards, or the intent of the safety standards. We need to be creating a pathway for those sort of occupant-less vehicles to operate. And so what we've seen first, of course, this exemption. Next, NHTSA has started to update some of these standards. Most recently at a proposed rulemaking on the 200 series, which pertains to occupant protection. But basically, if you're transporting a pizza or groceries, it isn't quite as important that you're protecting what's inside of that vehicle, because those things can be replaced. What's important is protecting the road users around it. And so these revisions are starting to happen at DOT, and very pleased to see the progress that's being made on that front, because we need to be doing a real reassessment of what our standards are, where, as John said, these policy milestones, maybe not barriers, but milestones on how we can get these updates in place. And so it's exciting to see these happening, and to see that the Department of Transportation has been focused on making these revisions.
So Warren, Greg said something interesting there. He was talking about kind of removing requirements that are, meant for human-driven cars. I think, in recent years, you've seen the introduction of kind of some state bills that require certain crew mandates on trains, on freight trains. Can you kind of talk about those, why those are the right or the wrong approach, and kind of how they fit in to kind of the ability to introduce and adopt autonomous technologies in rail?
Sure, Michael. If you think back, the rail industry is quite an old industry. Going back 150 to 200 years, railroads have been in existence. And a lot of the common business practices have, over the years, been embedded in those regulations. And so with the creativity, with the innovation, with the technology that is advancing us, it's important for us to move past some of those embedded business practices of 100 years ago that are codified in our regulations. Now, in terms of the state and the federal oversight of this, railroads and the rail transportation is a network industry. Norfolk Southern, you introduced me, is serving in over 22 states. And if we're not careful, we can have regulations that might compete or restrict or conflict. And so we don't necessarily feel like interstate commerce and state-based regulation is the appropriate way to pursue improvements in technology and automation and business practices and regulatory oversight. A patchwork of state laws regulating crew size would be very difficult to maintain and manage and would impede interstate operations. And we want to be very careful that we service our customers, we have the best customer service, that we're safe, we have capacity in our system. And by having many varied options of regulatory oversight, that would be an impediment, we feel, to the industry.
Mm-hmm. So I want to turn to you, John, now, because I feel like some of those crew mandates are coming from a place of trying to ensure safety. And I feel like for drones, so often I hear about kind of the need from the FAA for remote identification and for traffic management systems. So can you kind of just explain that to our audience, and how important are they? And are they something that we need to kind of, reach that milestone of having kind of drones be part of the day-to-day delivery operations?
I'll try. The first, air traffic management is critical to safety if there's going to be any volume involved at all. It's no different than the traffic light system that you have in the cars you drive. I grew up in the heavy aircraft world, flying for the military and flying for the airlines. And our team is composed of a bunch of customer service engineers, a bunch of truck slant electrical software engineers, and a bunch of flight ops, flight maintenance people. Because the FAA system works pretty well in terms of reliability and safety. There are lots of things that the FAA is working on changing in the small UAV world in particular that need work, but they're paying attention to it. And I think that's gonna put the country about where the country needs to be eventually, though we're a little slow out of the gate. UTM, traffic management, if you think about where I'm in Cincinnati, Ohio. We're operating 40 or 50 flights a day. We're operating from the same points of origination to most of the same points of destination. So there's a little congestion there, but we're the only operator. It's no problem. However, if DHL, UPS, FedEx, Amazon, the post office, drugstores, Lowe's, pick your poison, if somebody else wants to start flying as well under Part 107, and pretty soon there are, say, 5 or 6 operators, and now there are 100, 200 flights, it will become really important to be able to deconflict those. And in the drone airspace world, most operations are going to occur below 500 feet above the ground and lower. So you don't have the airspace available that you do in general aviation, commercial aviation, military aviation, 1,000 feet above the ground and on up to the flight levels. So there's not a lot of vertical separation available. You have to think a lot about horizontal separation. The work NASA is doing, we're participating with NASA on the Grand Challenge for UTM development, and as are almost everybody in the drone world, to play a part in understanding what are the best steps, the best ways forward. And it's going to be a layered approach that includes a pretty broad sensor array, passive and active, transmission and reception. It's going to include the ability to have automated and perhaps autonomous detect and avoid behaviors, so that when you're flying along and another aircraft conflicts with you, both of them do what they're supposed to do laterally and vertically. But more important than that, sometimes in the package delivery world, is to not think about the cooperative targets, another aircraft, but the uncooperative targets like a power truck or a tree limb or a person on a bicycle you didn't know was going to be there. the ability to avoid those kinds of things and move your aircraft around and still participate in the unmanned traffic management system are going to be really important. So the waypoints there to get to that, I think, are pretty clearly understood, and they're all in work by a pretty smart group of people. I think we can be pretty satisfied with the progress we're making in terms of direction. We could always go a little faster.
Greg, I would like to turn to you now because we kind of talked about the FAA's approach to this. When we think of kind of autonomous vehicles and the type of vehicles that might, be delivering kind of pizzas in the future more often, how is the federal government looking at this? How is Congress looking at this? Do we have the right approach? Do we need a new one? Please.
Yeah, there are a lot of parallels with what Warren and John were discussing. It's transportation by nature is interstate commerce, and you should have the ability to move goods or people with a vehicle without having to stop at every single state line, get re-inspected, and face really a patchwork of regulations for AVs. That's one area that's been a major focus at the federal level, really for the past 3 or 4 years. As those who are watching may know, Congress has worked on a iteration of AV legislation in this Congress, and in the previous one as well, in 2017 and 2018. Congress had worked on what really was a tremendous bipartisan effort. In the House, it was called Self-Drive. In the Senate, it was AV Start. Comprehensive AV legislation that would be the first step in setting the stage and updating and modernizing our regulatory system for AVs and ensuring that we're modernizing regulations and preparing for the future of them. Unfortunately, in the last Congress, there were some procedural hurdles and some opposition that was encountered. But I will say that, it's very rare in the 20 teens to be seeing bills pass in a unanimous sense. And it was incredible. Self-Drive in the last Congress passed unanimously out of subcommittee, out of committee, passed on the floor by House vote, on the House floor by voice vote. And in Senate Commerce passed unanimously. And the hope is that this Congress will proactively pass AV legislation before the end of the year. One key area where Congress can have an immediate impact is by allowing NHTSA to issue more exemptions for vehicles. As I mentioned earlier, Neuro was given permission to deploy up to 5,000 autonomous vehicles with different designs, but it's limited there, and the scope is rather small. Really, what we should be looking at is allowing for larger scale deployments where you can also manufacture them at scale, which is also critical, and enabling the U.S. to continue to be a leader. We've been leading technologically in AVs. The U.S. is really the birthplace of the modern AV development, starting back with the DARPA Grand Challenges in 2004, 2005. And we shouldn't see that leadership now because of inaction on updating regulations, preparing for the future. And, this carries across every mode. We're seeing, as Warren said, with PTC and with all these new technologies coming on board for rail, that there needs to be an awareness of the benefits that automation is going to bring in rail. As John said, we need to be looking at how we can implement UAS traffic management, how we can look at Part 107, how to really ensure that we're enabling innovation across every space, lest the U.S. Lose our technological edge because we failed to sharpen our policy edge.
So that's bring up an interesting topic there in terms of competition, because we may be losing our policy edge. So I guess you mentioned that you hope AV legislation, autonomous vehicle legislation gets passed by this Congress. I guess I would ask you, how realistic of a hope are conversations still happening around that? And really, when you mentioned from a competition standpoint, are there anything else, for any of these technologies that other nations are doing well, either from a technological or policy standpoint, that you think the U.S. could learn from?
Yeah, let's start with Congress, which if anyone who says they have a crystal ball into Congress is probably lying to you. So I'll refrain from doing so. But what I will say is that in my previous role at SAFE, we published a report, Get America Moving Again, that looked at what Congress can do to stimulate the economy through making sound investments in our energy and transportation sectors and new technologies, and also through updating regulations. There are things that Congress can do right now without even spending money to support the AV industry. Expanding exemptions, for example, expanding the exemption cap of 200,000 vehicles per manufacturer. That's inherently stimulative. We can start building those vehicles, and it would be of immense benefit to our companies here. You know, when we look abroad, though, to what other countries are doing, the U.S. has really not moved quickly enough and has not been adaptable enough in enabling these technologies. For example, I'll point to China, for example. When COVID hit China, one thing that the Chinese government had done really well, actually, was enabling the deployment of autonomous purpose-built vehicles to disinfect city streets. They also disinfected 2,000 hospitals, transported goods and groceries to essential workers, and provided regulatory flexibility to companies to be able to do that. In the US, we haven't quite seen that willingness to be agile in our response and to enable the deployment of technologies that will help to solve some of these issues. And what I will say is that I want to be very clear. Vehicle autonomy is not going to cure COVID. we know that is true, but what autonomy can do is help to help the essential frontline workers to receive goods through contactless deliveries. It can help to serve patients, and it can help people who are staying at home to receive deliveries in a contactless way. Of course, we're still fairly early on in some of these deployments, but the potential that we're seeing here is tremendous, and it's really invigorated, I think, a lot of attention into what the potential for autonomous deliveries is.
Warren, so Greg mentioned that we're still pretty early on in the adoption, say for some of those technologies for autonomous vehicles, but we talked about positive train control before, but how far along in that adoption are we? How far along is Norfolk Southern, and kind of what are the benefits we've already seen from that?
Right, very, very good. Now, remember, the energy management solution, working with positive train control, provides for the safe operations of the locomotive in very much a cruise control manner. So currently at Norfolk Southern, we have filed with the FRA our footprint for positive train control deployment, and we have completed implementation of the technology at the wayside, at the track level, within our locomotives, in order to accomplish positive train control. Additionally, we've equipped our locomotives with the onboard energy management solution, the onboard PTC solution, and we are actively running PTC today, even though the deadline is not until later this year. And we're also achieving the sustainability, the fuel opportunity savings with the energy management solution on board the locomotive. And we're doing this through automation. In essence, the engineer comes on board the locomotive, and as he reaches a certain speed, he can engage auto throttle or auto run. And in essence, the locomotive drives itself across the track network. So we have recently established compliance metrics that helps us gauge the amount and the adherence to our energy management savings plans, and also our positive train control directive. And so both of those are very active right now in our on our network and across the entire rail industry.
You mentioned the Federal Railroad Administration's requirements, but I also read, I think it was in 2018, that Norfolk Southern responded to a request for information from the FRA stating that the FRA should affirmatively signal its willingness to embrace and encourage automation in the rail industry and begin reviewing and removing regulations that impede innovation in favor of performance-based regulatory scheme. So can you just talk about how the FRA has responded since 2018? And really, what are those policies that Norfolk Southern believes that they could remove that would help promote innovation and the introduction of automation?
Great question. And two specific examples I'll share with you. Traditionally, for track inspection, the thousands and thousands of miles of physical track that we have on our rail network, that was required to be accomplished periodically at a certain frequency and also by human inspection or observation. And what we've done recently is we've equipped several dozen trains with a laser underneath the locomotive and sensor data to look for microscopic stress fractures or wear, unusual wear, capture that, offload it, and assess it in the back office. So think about the technology jump that has occurred with humans eyeballing a section of track and us using lasers to identify defects. Now, we are working with the FRA for an exemption and a pilot to continue using that as a replacement for the human inspection, as are other railroads doing this as well. And so that's one example of us working jointly with the FRA to implement innovation and creativity to replace some of these legacy, very manual processes. Another quick example that that the rail industry is working with the Federal Railroad Administration on is with the introduction of PTC. We have the ability for our dispatch group, almost like our air traffic controllers, to convey track authorities or authority for movement to the trains. And traditionally that's been done by a very read, copy, and repeat type scenario where we get on data radios, the dispatchers talk with the locomotive engineers, and that conversation goes back and forth. And there is potential error implied in that because a number could be transposed or there's challenges there. And so we're currently working with the FRA for an exemption to use electronic only mandatory directive conveyance. And in essence, what that means is the computer very accurately packages up the authority to move to a train, and it delivers that through technology to the onboard locomotive through wireless communications. And then that locomotive with energy management and PTC on board can operate to that electronic package and limits of authority for movement. And in so doing, it really takes a human error factor out of the equation. And I think that's one of the big advantages as we move towards autonomy and autonomous operations, is really moving that human error factor that can potentially creep in and cause issues.
So, John, I want to turn to you now because Warren was just talking about removing the human error factor. But I think maybe you mentioned before, there's some situations where we won't have drones flying over schools or maybe hospitals or churches or things of that nature. And that kind of brings up maybe some people's concern if there's ever such a loss of control of the drones, if the drones are malfunctioning mid-flight. So can you just talk about, I guess, what companies such as yourself are doing to, I guess, combat against that concern?
Michael, I just got a note that said my internet is unstable and I couldn't hear your question. Would you mind asking me one more time?
Sure. So Warren was talking about removing human error from certain processes. And you mentioned earlier that there may be some situations or some areas where you don't want to fly a drone over, like a perhaps a school or a church, I believe you mentioned. And that kind of brings up the concern that I've heard from some people, that is, what happens if there's loss of control of the drone during flight or the drone kind of malfunctions. And I'm interested in hearing kind of what Workhorse has done to kind of, I guess, combat against that concern that somehow the drone could, malfunction mid-flight.
Sure. Warren touched on so many points that resonate with us in terms of human error and the human factor in design. The last 100, 200 years of Norfolk Southern's legacy and how they're going to get away from that moving forward for the next 100 years of railroading. That's the way we think about aviation too. So 100 years ago, when Orville and Wilbur were flying, there was a pilot and a machine and a motor. In our aircraft now, there are layers of control. So not just one pilot anymore. There's a flight plan that's been put in to an autonomous system. There's a communications backup that ensures the aircraft is performing to what was planned, both external to the aircraft and internal on the aircraft. So if the external link is lost, the internal aircraft piece knows what it's supposed to do and can go do that automatically or autonomously, depending on whether it has control from the ground or not. Then there is a third link, which is the human intervention. If the GPS signal is lost, for instance, a pilot can manually take over from a remote location. If the inertial system is lost, the GPS can take over. If both are lost, the person on the ground can take over. We have a layered system that allows for safety to exist in any degraded state. The term people use all the time is the graceful failure. We need the ability to have one or two critical systems fail and the aircraft to respond reliably and either complete the mission or recover because it cannot complete the mission in a way that's seamless to everybody around it. And the next 100 years of aviation are going to take full advantage of the things that Greg and Warren have been talking about of AV ops and this whole notion of cruise control to a very, very high degree of fidelity and efficacy so that the machine does everything that you would expect it to do to a really tight set of tolerances and required navigation and vertical precision and mechanical and systemic reliability.
So I want to bring in some of our audience questions now. The first question would be for you, John. So you mentioned earlier about how a CVS or a Walmart in a neighborhood could go around and kind of, I guess, petition the community and see if they, would want to sign up for, say, drone delivery. One of our audience members is asking kind of really, how would the fleet management of drones work? So if you take the example of a drone provided to a local CVS, who's maintaining that drone, who retrieves it, if something does malfunction mid-flight, if you could kind of walk us through that implementation scenario.
Sure. In the United States, the Federal Aviation So original equipment manufacturer of an aircraft, which we are, we sell our aircraft in the marketplace. Bob's drugstore down the road would buy 10 of them, and they would buy a maintenance program from us that said for every day of operation, you're going to run these checks. And if things don't work, you're going to replace these parts. For every 100 hours of operation, you're going to run this deeper set of checks. Every month, you're going to run this bigger set of checks. Every year, this bigger set of checks. And for all of the 80 or 90 critical parts that are on a given system, we're going to tell you when you replace them and you should look for when you maintain it and how those pieces work so that you produce operational reliability through a maintenance reliability,
John, I think we're losing you.
We're going to train people so that,
okay. While we fix that real quick, Greg, I just want to turn to you because there was another audience member question, and it basically talked about how we've talked both about encouraging federal autonomy regulations, maybe to preempt state and local conflicts, but at the same time, we've talked about how, in some ways, some of these drone rules might be reliant on kind of local attitudes. So, Greg, how should we be balancing those two concerns, either state and local versus federal?
Yeah, in a past life, I worked at the ENO Center for Transportation, and we wrote one of the first very broad sort of looks at federal, state, and local responsibilities in regulating AVs. And the fact of the matter is, it's going to be very similar to how we regulated vehicles in the past. We should have a consistent national framework, so you should be able to drive a vehicle from coast to coast without having to stop at every state line, as I mentioned. But also, states and localities have a lot of responsibilities in managing surface transportation. This includes setting insurance standards. This includes setting and enforcing traffic laws. And they have a lot of authorities at their disposal. What many AV companies do before starting serious pilot deployments is engaging with cities and engaging with state leaders and engaging with local law enforcement and providing them with insight into, how do you pull over the vehicle and how do you interact with the vehicle. That work is happening, and a lot of that, of course, is ad hoc at this time, and it entails a lot of education. But really, the best framework for overseeing, future AV deployment is to continue to have that regulation of what's between the bumper to bumper, which is known as Federal Vehicle Safety Standards. That continues to be at the federal level, but working with states and localities to ensure that state and local laws are, of course, being followed, and also that people are comfortable at the local level. People are excited about autonomy when they get introduced to a vehicle, and fascinated. I remember my first ride. I was over the moon, right? I had gotten the first AV that I'd ever been in after working on it for a few years. But the incredible thing is, after you're in an AV, you're interact with an AV for a few minutes, it's just another vehicle, right? Which is really the interesting part. I got on my phone almost immediately when I was checking it. And so that interaction, that exposure, I think it's going to be very important, and it's going to show people what the benefits of autonomy are. And that's really what the case for autonomous delivery is. This is the first place where people can be quickly exposed to AVs and to see that, most people's time when they're driving, about something like 40% is spent running errands. So when they see the benefits of an AV helping them to do their daily tasks, their grocery shopping and things like that, I think that's going to be people's first and perhaps a very impressionable, positive first exposure to autonomy.
So Warren, I want to turn to you now too, because we've kind of been talking about different regulations, both at the local level and at the state and the national level, but we've also been talking about different regulators. We're talking about the NHTSA, the FRA, the FAA. So we have these different technologies. Sometimes they're facing similar milestones they have to meet, but they are different, and they have different regulatory bodies overseeing them. So how do we kind of ensure that we're not, I guess, advantaging or disadvantaging kind of one technology or one form of automated delivery over another?
So that's a great question. I think it's very important, it's vitally important, that the government should not really create a distortion that disadvantages the rail industry over the trucking industry, or the trucking industry over the private vehicle industry. The fact is, the railroad moves goods very fuel efficiency over a privately funded and maintained network. And so it's very important for the rail industry to have an equally accessible path to innovation, using this creativity and innovation to move forward without, regulatory encumbrances. So I do feel like it's important to keep it equitable and just across all the modes of transportation.
Greg, I'd like to get kind of your opinion on that, kind of use your past experience, both as, Center for Transportation in your former role. I mean, how does that kind of happen in practice? Should these regulators at these different agencies be talking to each other? Should someone be reviewing this within the federal government and seeing, how are we treating different technologies?
Yeah, I think that's a great question. And what does stand out, at least in terms of automation, in January, the U.S. Department of Transportation published Automated Vehicles 4.0, which basically served as a world atlas for all the activities that the Department of Transportation is pursuing around autonomy. And it included Federal Railroad Administration, and I believe there are a total of 38 agencies at the federal level that are working on autonomy and have assessed autonomy. This is an important first step, is making sure that we are enabling innovation across different sectors. And also, of course, the innovations in one mode also serve to benefit the innovations in another mode. And a lot of the technologies that are used build on each other. Warren was mentioning using lasers to sense defects in the tracks and to prepare for maintenance. Lasers just like that. Laser sensing is what's used in LiDAR for driving autonomous vehicles. And there are also multiple applications that we're seeing not just in the transportation sector when we allow for this innovation, but some of them are being ported over into other fields. For example, the machine learning algorithms that have been used for self-driving vehicles have been used in some cases, in some trials, for also detecting, helping doctors detect cancer earlier. So what we're seeing is this cascading effect of these new technologies helping to serve other fields and yielding broader benefits. And, it's absolutely the same across every mode. Transportation is, as I like to say, is an ecosystem. And the health of each part of this ecosystem serves the broader community better and helps to drive innovation across every space.
Mm-hmm. John, I think we have you back. So the next question I'd like to first pose to you, and this is from someone watching it online, and they basically ask, what metrics should be used to delineate between different drone classifications? Should it be their weight, their width, their speed? Can you talk a little bit about how we do differentiate and kind of regulate different drones, maybe already in the United States, and maybe how it should be in the future?
Sure. There's a matrix that the FAA uses as it thinks about drones and performance. The first bucket is what's called a small unmanned aerial system, 55 pounds or less max takeoff weight. I think it's 100 knots or less speed. And the notion there is, how do you manage the kinetic energy of the vehicle should it hit something? Just what's safe and what's not. The FAA has published, the international community has published a very similar document, a safety continuum, that talks about how you think about regulating something from a 30-pound thing that flies for 30 miles an hour for 10 minutes to a 747 and everything in between. And the organization is trying to regulate to the standard of what is a reasonable person's approach to safety for the risk that we're asking the public to take. Yeah. The FAA's view has always been, it's not enough to say that we're regulating the operator, we also have to regulate for the public good. So what does that look like, and how can you make it the most efficient thing possible that is still taking care of people on the ground below? I love what Greg said earlier about how sometimes regulation falls out of step, because all you have to do in our industry is look at where capital flows around the world to see what our industry thinks about where opportunities are the most prevalent and where you can move the farthest, the fastest to get things done. And it's not always here, but that metric that people use, size, weight, speed, altitude, is the common one.
So what you said there at the end is very interesting. You said people look at capital flows to see where organizations think they can innovate and demonstrate this technology. So is there anywhere particular you're thinking of, and is there anything like that U.S. policymakers, regulators can kind of learn from how maybe other nations are regulating drone technology or implementing it?
Michael, I couldn't hear you again. I apologize. I'm going to have to go find another place for the next one.
If you can hear me now, basically just saying, what can we learn from other nations? Because you mentioned that some other that capital has flown to some other countries for this technology.
I think that, to Warren's point, creativity and innovation doesn't just live here. There are a lot of good ideas all around the world, and to the extent that somebody is getting something faster, it's not necessarily a zero-sum game, but it's absolutely true that someone's going to win and someone's going to lose in every significant development coming forward. Whether it's cruise control on a train, or whether it's the ability to have Neuro be able to deliver 4,000 vehicles worth of stuff, or 5,000, excuse me, when somebody else got the ability to do 10,000 faster. We think all the time in terms of, if someone's going to win, why shouldn't it be us? It ought to be able to be something that the nation can get right, to find the right balance of safety and compliance with speed and delivery of service to our people. That's what we're focused on all the time. And what I would tell you is, We work really hard at an up close and personal level with the folks who regulate us. By and large, that is one or two agencies, the FAA being the dominant one. Listening to Warren talk about the challenges he faces in the 22 states he operates in, that would be really hard for us. If we had to Greg's point, talk to somebody different when we flew across the river from Ohio to Kentucky, before we could do that, that kind of impediment would be a really hard thing for us to manage through. Mm-hmm. So I would tell you that the ability to work with one set of regulators, and the ability to have good relationships with those people and to have them be expert at what they do are extremely important and powerful. And to the extent that we can have the smartest people in the right office working with the smartest people in our office, I think everybody wins.
Yes.
So we have just under 5 minutes left in the webinar today. So I want to start to talk about kind of the effects possibly on labor. I think that's one of the concerns or pushback we, generally always see against automation, is because, people are concerned that jobs will be automated away. So Warren, I want to kind of turn to you and kind of just talk about, what are the effects we've seen in automation on kind of the labor force and the rail industry, and what should we be doing to kind of help those workers? Should industry be helping them? Should it be the government? Should it be a combination? But be interested to hear your thoughts.
All right. So in the rail industry, we feel that, autonomy and innovation, creativity, really enhances the safety and work life. It enhances the work life of the employee and the individual. It makes them more advanced and marketable across industries. We feel like many of our employees grow up with technology in hand. And so it's an easy transition to continue their personal and their work environments using technology than it is to step back and go into manual patterns of work. So we really feel like it's an enhancement to the work quality of life. We know that it reduces, human factor errors. And so we feel like that's a very positive thing. And with advances in technology, we feel like we're very equipped to offer training through the use of simulation, virtual reality, applications that help us understand how to weld track segments together, maintain track segments, simulation runs of a locomotive, very similar to gameplay. And so there are a lot of enhancements that we are doing to empower the employee to embrace this technology and to move forward as well. So we do feel like it's a benefit to the employee, and it grows their skills over time.
Greg, I'd basically like to ask the same question of you, but when you think about the broader ecosystem of kind of the autonomous technologies that we'll be using to deliver goods in the future, and how do you think that's going to affect kind of the labor force, and what can we do to, make that transition?
Certainly, there are a few things. The first is that my prior employer, Securing America's Future Energy, SAFE, actually published a report 2 years ago called America's Workforce and the Self-Driving Future that looked at the impacts of autonomy on the workforce. There was a lot of rhetoric about how AVs would affect the workforce, but not a lot of statistics before this was released. What was found was a few things. Number one is that autonomy will be introduced over time. This is not going to be an overnight, all of a sudden every truck is going to be autonomous. And also, there's currently a shortage of about 50,000 truck drivers at any given time. Even if you introduced every new truck that's put on the road today was autonomous, we wouldn't be displacing any workers. Nevertheless, the impacts we will see on jobs from AVs will be diffused over a 30-year period. This transition will take time. Investing in new autonomous trucks will take time. And also there are many tasks that where you need a driver in the truck in order to perform certain maneuvers. Another thing is that AVs very closely resemble other transformative technologies, like the ATM, for example. When ATMs were first introduced, it was heralded as maybe the end of the bank teller. But what we in fact saw was that now there are more bank tellers than ever. And banks were able to open up more rural branches by allowing the physical bank tellers, the humans, to perform more of the human tasks of helping customers in person, while the tasks that could be automated, such as distributing cash, was automated and improved the efficiencies of banks in rural areas and otherwise. The third and last thing that I'd like to leave everyone with is that the research found that AVs promise to deliver nearly $800 billion annually in social and economic benefits by reducing collisions, by reducing oil consumption and moving to electric vehicles, and by increasing job access for people who are in areas where transportation services might not be sufficient or affordable. So there are a lot of benefits of autonomy that we're going to see delivered and distributed across the entire transportation sector.
So we're out of time, and I think that's a good place to end on that positive note. So I want to thank our panelists for joining us today. I want to thank our audience for watching. We hope to continue to engage with you on this issue. And before I go, I just want to kind of give a plug to ITIF's new podcast, Innovation Files. I believe you can listen to that on kind of any podcasting listening platform that really talks about a lot of some of the biggest tech issues that we're facing today. It's not issues with autonomy, but also kind of issues of competition with China. But anyways,